StepWise is a tool that allows you to write proofs and have them checked at each step to make sure that they're correct. Let's do a Boolean logic proof that will need to exploit both identities and inference rules. Assume the following premises. If Morgan has no cat, then Pat has no cat. And if Dana has no cat, then Zach has no cat. If either Morgan has a cat or Pat has no cat, then Zach has a cat. If Dana has a cat, then it's not true that both Robin and Stacy have cats. Let's prove that Robin or Stacy has no cat. We'll start by defining the symbols that we'll use to encode these claims. So, let M be Morgan has a cat, P Pat has a cat, D Dana has a cat, Z Zach has a cat, R Robin has a cat, and S Stacy has a cat. And now we need to start by rewriting the premises and the goal as formal logic statements using these variables. So, not M implies not P, and not D implies not Z. M or not P implies Z. D implies not R and S. And the goal is to prove not R or not S. All right, here's the setup. We have three premises, 1, 2, and 3. And here's the claim that we're trying to prove, not R or not S. So how to start? Well, one of the things we notice is that premise 1 is actually the conjunction of two claims. Let's split it apart so we can use them individually. So let us choose premise 1. And now we need to figure out what rule we can use to split it apart. And let's say we're not sure. So let's turn on the funnel and click here. And now we get a list just of the rules that apply to the claim that we have decided to start with. And we can scroll down and we see that there's simplification. Let's give it a try. So if we're not sure and we don't want to make a mistake, we can click Book and it'll tell us the definition of simplification, and that looks like exactly what we need. If we wanted, we could also click Wrench, and it would actually tell us what we'll get if we apply simplification to the particular claim we're working with. And notice that there are two things we could get. We could pull out either of the individual claims. So that's what we want. Let's now enter our step. If I click here to position the cursor and then double click on premise 1, there it is. And now all I have to do is edit, and I can remove the piece I don't want. I've taken the first piece. I clicked the check mark, and it's right. So I now have a new premise. All right, so what shall I do now? Often it's good to get rid of implication unless you have reason to believe that you're going to need it with an application of modus ponens. And there's nothing where we have a not M, so that doesn't look very likely. So let's simplify that. Let's take the claim we just made. Let's use conditional disjunction. I can just type a C, and I'll start to get only those rules that have C's there. Okay, conditional disjunction. Note that the claim from last time was left right here, ready to work with. So I can insert a not, and I can delete the implies, and I can add an or. All right, let's see if that's right. Sure enough, that's good. Now we almost surely want to get rid of the double negation. So let's again go with the claim we just made. Let's use double negation. And let's erase the two nots. Let's see if that's right. Okay, good. Now we have M or not P. And if we look at premise 2, we see that M or not P implies Z. So that looks like something we might want to do. Let's try that. So let's use M or not P implies Z, and combine that with M or not P. By the way, if we are about to apply a rule that requires two inputs, it doesn't matter what order we put them in. Either can be in either of these boxes. And we're going to use modus ponens. And we're going to derive C. In this case, it's easiest probably just to erase that. And we can click Z here, or we could type it. All right, good. Now we have Z. What can we do with Z? Well, we have the other piece of premise 1 up here that involves not Z, which we might be able to use. Let's do simplification again. Let's take premise 1. Let's do simplification. And this time, we're going to pull off the second piece. I'll eliminate Z here. I'll stick that premise in here. And this time I'll erase the first part. So I've got the second piece as a separate claim. All right, now what? Well, we've got Z and we've got not Z. One way to view Z is that it's not Z. And if we view it that way, we could combine it with 8 using modus tollens. StepWise is a bit generous. Sometimes it allows us to combine a very simple rule with another one so that we don't have to write quite as many steps. And it's going to let us do that in this case. If you're not sure, you can try. But what we're going to do is we're going to take 7 and 8 and try applying modus tollens. And let's see what's going to happen. So we have not Z, and not D implies not Z. So this means we should be able to derive not D. Let's see if that's true. We'll try not D, and let's see what we get. Yes, that's fine. Now let's get rid of the double negation. Almost always want to do whenever we get it. So we'll take double negation, and that gets us D. All right, now we've got D. Note that we've got D implies, not R and S. Let's select D, and D implies not R and S. Let's choose modus ponens, and we should be able to conclude. Not R and S. Let's see if that's right. Good. And that's very close to what we want. We have not R and S. We want not R or not S, which we can get by a single application of De Morgan. So let's use our last line. Let's use De Morgan. D-E, De Morgan. Okay, and let's get, that will give us not R or S. But we made a mistake. I forgot to get rid of that parenthesis, so it tells us. So that's fine. We just go here and fix our mistake. And I made another mistake, which is that I failed to put the not in front of both of the claims. So we fix it, and we're done.